Here I will give some more example on Cauchy type equation. Next example is solve x square d square minus xd plus 1 of y equal to sine of log x. So here also we can take the transformation. Let x equal to e to the power z, and so z will be nothing but log x, and because of this xd will be d dash x square d square will be d dash into d dash minus 1. And if we substitute this one in the given differential equation, we will have d dash minus 1 minus d dash plus 1 of y is equal to sine of z. Sine of z. So because log x is z, and what we will get here, d dash square minus d dash plus 1 of y equal to sine z, and d dash square minus 2d dash plus 1 of y equal to sine z. Now this is a constant coefficient differential equation, so we can have the auxiliary equation as m square minus 2m plus 1 equal to 0, and m minus 1 whole square equal to 0. That means m equal to 1 comma 1. So the nature of the root is real and repeated, and therefore complementary function will be c1 e to the power c1 plus c2z into e to the power z, because it is 1, and you know that z is log x, so c1 plus c2 log x, and e to the power z is equivalent to x to the power 1, because 1 is nothing but this root. So this is the complementary function. Now let us find the pi, and pi will be nothing but 1 by d dash square minus 2d dash plus 1 into sine z. So here what we will do, we will replace d dash square by minus 1 minus of 1 square. So here a equal to 1, so we will replace it by minus of 1 square, and the remaining thing will be 1 by minus 1 square minus 2d dash plus 1 into sine z. So you find here minus 1 plus 1 will get cancelled, remaining thing will be minus 1 by 2 into 1 by d dash into sine z. 1 by d dash means integration with respect to z, and so this is equivalent to minus 1 by 2 integration of sine z dz. Integration of sine will be minus cos, so it will be 1 by 2 cos z. But cos z is nothing but log x, so 1 by 2 cos of log x. So this is your pi. Once after getting the pi, you can write your complete solution as cf plus pi. cf plus pi. That will give you the complete solution. Another example I would like to tell you. Example, solve x square d square plus 4xd plus 2 of y equal to x log x. So here also we will use the transformation x equal to e to the power z and wherever z will be there we will put is log x, and because of this transformation xd will be d dash and x square d square will be d dash into d dash minus 1, and if you put here what we will get, we will write here d dash into d dash minus 1 plus 4d dash plus 2 of y equal to x equal to e to the power z and log x equal to z. And so we can write here d dash square minus d dash plus 4d dash plus 2 of y is equal to z into e to the power z. This is in case of constant coefficient, this is type 4. So now what I will do here, I can further simplify it and I can write d dash square plus 3d dash plus 2 of y equal to z into e to the power z. Okay. So now we will write the auxiliary equation. Auxiliary equation will be m square plus 3m plus 2 equal to 0. So m plus m square plus 2m plus m plus 2 equal to 0. And so m plus 2 into m plus 1 equal to 0. That implies m equal to minus 1 and minus 2. So the nature of the roots are real and distinct. So the complementary function will be C1 x to the power minus 1 plus C2 x to the power minus 2. This will be the complementary function. Now we will find the particular integral. The particular integral will be 1 by d dash square minus 3d dash plus 2 into z e to the power z. Now this is the type 4 problem. So we can take out e to the power z by replacing d with d plus 1. And we will get it like this. E to the power z will be outside 1 by d dash plus 1 whole square. Wherever d dash is there, we will replace it by d dash plus 1 because here e to the power 1 z is there. Minus 3 into d dash plus 1 plus 2 into z, and e to the power z will be outside, and then here d dash square plus 2d dash plus 1 minus 3d dash minus 3 plus 2 into z. Now you simplify it and rewrite it again. It is equal to e to the power z 1 by d dash square 2d dash 3d dash minus 3d dash. So minus d dash and then 1 1 and 1 plus 2 3 minus 3 0. So this one, this 2, this 3 getting cancelled into z. Now what I will do here is I will take e to the power z, I will take out and I will write it as minus d dash I will take out. So I will have 1 minus d dash, 1 minus d dash, and so I can write it minus e to the power z into 1 by d dash and 1 minus d dash to the power minus 1 z. Since the degree of z is 1, so we will write the series. This implies e to the power z minus e to the power z 1 by d dash will be as it is, and the series expansion will be 1 plus d dash plus d dash square and so on so into z. Since degree of z is 1, d dash square and thereafter all the terms will be 0. And so what will be the thing, we will have minus e to the power z 1 by d dash and z plus 1. And this is equivalent to e to minus 1 by d dash means integration with respect to z. So minus e to the power z integration z plus 1 dz. So integration e to the power minus e to the power z into z square by 2 plus z plus z. Now z equal to log x. So e to the power z will be x. So this will be minus x into log x whole square by 2 plus log x. Okay. And so this will be equivalent to minus x log x into 1 plus log x by 2. So this is your pi. Once after getting the pi, you can write the complete solution as complementary function plus particular integral, and that will be your complete solution.